Homework Hotline, what is your emergency?
Hello everyone, welcome to the Homework Hotline. We are coming to you from the DPS TV studios.
Here's a shout out to anyone watching us live on Comcast Channel 22, Prism TV Channel 8007, YouTube Live at Denver DPS TV, Facebook Live at EG Homework, or live stream at livestream.com/DPS TV 22. Hello.
So you may be asking yourself, why are we live and in so many places? Well, that's because we want to give you a lot of viewing options so you can get all the homework help that you need. And we're also here every Tuesday and Wednesday from 4:30 to 5:30 p.m.
Give us a call and we can interact with you here on the show. If you really are having a hard time understanding the problem, we'll work you through it. If we need to clarify something in your question, we can ask you. So calling is really the best way to get your question answered. Our phone number is 720-424-1666.
The Homework Hotline is sponsored by Contemporary Learning Academy and Emily Griffith High School. Do you need help with math? Well, I'm Nathan, and I can help you with that. I teach math at Emily Griffith High School.
And if you need help with science, I'm your go-to person. I'm Sam. I teach at the Contemporary Learning Academy.
I will also help you with math. I'm Becca. I also teach at EGHS.
So later in the show, we're going to have Jason Shafer, the principal clarinetist from the Colorado Symphony. You'll want to watch this interview. It will be off the scales.
Though we prefer to get your phone calls, we know calling isn't always the easiest thing for you to do, so we have someone monitoring our social media. Jack, why don't you tell the audience about yourself?
Well, as you just said, I'm Jack. I'm an intern here at DPS TV. As you mentioned, we will be taking your questions over social media. I'm the one who grabs those questions and relays them. By the end of the show, I want to hear an answer to the trivia question we have coming up here in just a second. If you do get this trivia question correct, there will be a prize. So if you can, take a shot at that question. Our question today is a geography question. Which state in the continental United States has the most navigable waterways?
So if you have an answer to that question, as Jack mentioned, there will be a prize. I believe it is Symphony tickets, which is very cool. So, and guessing is not penalized, but you can get a hold of us with the phone number that I gave you earlier, that's 720-424-1666. But as we mentioned, you also have social media that you can get in touch with us on. Those you'll see on your screen in a second are on Facebook, on Twitter. You can reach us at EG Homework. Those are our Facebook and Twitter handles. You can text us at 970-680-3771. And then you could also email us at homework@emilygriffith.edu. So just like all of the options to watch us, you have a lot of options to get in contact with us as well. We will be here until 5:30 to answer your questions. So until then, let's go back to Jack and see what we have waiting for us on social media.
So it looks like today the first question we're going to be dealing with is a science question. It reads like this. Locate carbon on the periodic table and then locate bismuth at the bottom of the group, which has a larger atomic radius. How about carbon versus boron, which is in the same period as carbon, just one position to the left? That question came from Stephen Leonard, so it looks like we're going to be locating some things.
Okay, cool. Yeah, so I've got a periodic table up, but first let's just talk for a minute about what atomic radius is. So atomic radius is just defined as the distance from the center of the nucleus of an atom to the outermost area of the electron cloud surrounding that atom. When we think about atomic radius related to the periodic table is arranged in such a way that it gives us an indication of how large the atomic radius of one element would be compared to another. So if we jump to my screen, I've got a picture of the periodic table here. So the question asks to locate carbon. So carbon's right here. Carbon is element number 6 because it has 6 protons. And so the trend for atomic radius is that atomic radius gets larger as you go to the left across the periodic table and down the periodic table. So, and the reason for that is that the reason that the atomic radius gets larger as you go to the left on the periodic table is, if we think about carbon and boron, I know that's the second part of that question, but I'm going to start here. If we think about carbon and boron, carbon has a smaller atomic radius than boron does. And the reason for that is carbon has an additional electron, neutron, and proton compared to boron. And protons, being positive, attract electrons in the outer electron cloud. And so because carbon has an additional proton, it's going to hold its electrons a little bit closer in a tighter configuration. And so the distance from the center of carbon's nucleus to the outermost part of its electron cloud is going to be slightly smaller than boron's, which has a slightly weaker pull on its electrons. So boron would have a larger atomic radius. And I can actually show that. Here's another picture. This is sort of a chart that indicates the trend in atomic radius. You can see a generalized size, a comparative size of all the atomic radii. And you can see that as we go left across the periodic table, those atomic radii get larger. And as we go down the periodic table, they also get larger. So here's my arrows over, I don't know if it can be seen very well, but carbon and boron, you can see that boron has just a slightly larger atomic radius than carbon, again, because it doesn't have such a strong hold on its electrons. Looking at carbon again, bismuth, I think, was the other one, right? Mm-hmm. It was down the, let me jump here really quick. So here's bismuth, which I guess is right, it's one group over, but several periods down. And so even though bismuth is to the right of carbon, bismuth is so far down the periodic table that it has many more protons and many more neutrons and electrons added, which makes its radius much greater than carbon or boron. So again, looking here, here's bismuth. It's this purple guy. It has a much larger atomic radius than carbon or boron. So, and again, the periodic table is arranged in such a way that it gives us an indication of lots of these trends, not just atomic radius, but also things like electronegativity and metallic character. And things like that can be gleaned about one element compared to another just by looking at the periodic table. So.
All right, is it about time for a math question?
It
So you
is.
ready to jump right in?
Yeah.
All right, so over here on Twitter from Katie Harrison, we have a question about fractions. She needs help dividing fractions. So what is 6/11 divided by 8/11?
Well, I'm going to toss that over to Becca because she is like the fractions queen at our school. So
Was it 8/11? Is that right? 6/11 divided by 8/11?
Yes.
Did I hear that right?
Mm-hmm.
Okay. Okay. All right. Well, I guess the first off, I'll explain what it means when we divide fractions. Sometimes fractions are so abstract that we end up not really understanding what we're doing, and sometimes that's where we get confused with fractions, is because they are abstract sometimes. But what we're basically asking when we're doing 6/11 divided by 8/11 is we're asking ourselves how many 8/11 go into 6/11. So if we think about the size of these two fractions, 8/11 is going to be larger than 6/11. So our answer should be a fraction less than one whole is one thing that we should expect. So we're finding out how many of these go into the other. One other thing that is important to know is that anytime you're dividing by some number, so I'll give you a little example on the side here. And this is something, a concept that'll carry you through high school mathematics and even upper level mathematics, that if you understand this concept, you're making your life a lot easier. But when you're dividing by any number, it's the same as multiplying by its reciprocal. So the reciprocal is the inverse of a number. So let's see, here's an example. If I had 3/4, the reciprocal is 4/3. If I had 1/2, the reciprocal is going to be 2/1, which is the same, as just 2. So if I divide by 2, it's the same as multiplying by its reciprocal, 1/2. If I divide by, again, 3/4, it's the same as multiplying by 4/3. And that concept is really important because multiplication with fractions procedurally is not too bad. You just multiply numerators, multiply denominators. So if we can change our problem to a multiplication problem instead, it's going to be a lot easier to deal with. So instead of writing it as divided by 8/11ths, just like with the 3/4, we're going to change it and write it as times 11/8. And so if I rewrite it this way, this is saying the same exact thing. And the reason this works is just because division and multiplication are inverses of each other. Now, there's a trick that I taught my kids before, and some teachers teach this, some don't, but we can simplify our fractions before we multiply. And so you can think of this as, and I'll show you why this is. So when I multiply across 6 times 11, it'll look like this. There's my numerator. And then 11 times 8, there's my denominator. So 8 times 11. If you notice this here, they all end up on the same, if you have 2 numbers on the top, they'll still end up on the top. 2 numbers on the bottom, they'll still end up on the bottom. So you can see that here. And if you notice 11 over 11, that's just one whole, and multiplying by one whole is not changing it at all. So hence those 11s can actually be simplified before you multiply. Then we end up getting 6/8, and we can actually simplify those more. And the way we know that we can simplify is if the same number goes into both the numerator and denominator. So both of these numbers can be divided by 2. And we get 3/4 for our simplest answer. Which makes sense, again, is how many 8/11ths can fit into 6/11ths? Well, not the whole thing, just 3/4 of it. So there's some fraction division. But multiplying by the reciprocal, that's a really important thing that can help you with some upper level math later on as well.
Yeah, I find that a lot of students forget that when they are dividing fractions because they don't understand it conceptually. They were just taught to flip it and multiply.
Keep it, change it, flip it, or
yeah, all these different
copy, dot, flop.
easy ways to remember it without understanding what they're actually doing.
Right, exactly. All right, well, let's go back to Jack, and I think we have another science question waiting for us. Is that correct?
We sure do.
All
this
right.
one seems like
goody.
it might be
goody.
a little quicker, but I'm not the one who knows that. What's the difference between a biome and an ecosystem?
Jack, I can talk forever, so I might.
No question is going to be too short.
Right. Let's see. So biome and ecosystem. All right, I can make this one a little bit. I think I can make this more in depth than just the straight up answer. So I think that sometimes, especially in the sciences, I see this. Maybe I'm partial to that because that's where I work. But in the sciences, there's lots and lots of terms and vocabulary, definitions that you're asked to learn in science classes. And a lot of times those terms and definitions are really important, especially to us as science teachers, because we look at students and want those students to be communicating using those terms so that they're being clear about what they're saying. Sometimes, though, I think that we focus so much on vocabulary that we sometimes lose track of really thinking about just what the difference between these things is and why that even matters. But in any case, a biome and an ecosystem are very closely related, but there's sort of an important difference. So an ecosystem is the interaction of all living things in a given area and the non-living things in that area too, and how they interact. It's sort of the environment as a whole. So, and you can have a small ecosystem or a large ecosystem, it doesn't matter. You can consider the Earth to be one ecosystem, one large ecosystem. You could talk about the bacterial ecosystem in this television studio, which exists. You can think about the ecosystem in a forest. And there's lots of different ways to define an ecosystem, but whatever area you pick, it's just the living things in that area and how they interact with each other and all the non-living stuff. A biome, which is sort of like an ecosystem, is really just a certain type of ecosystem. So if we jump to my screen, I have a map of the world. The world is broken up in this map into different biomes. So biomes are sort of like types of ecosystems, we could think of it as. So you can see that here in Colorado, we are in a temperate grassland biome according to this map. And the other thing about biomes is that depending on who you talk to, there might be only a certain number, there might be very many more. But calling something a biome is just an attempt to sort of generalize what types of living things you might find there. So like the grassland that we see here over Colorado should have similar types of vegetation and animal life to what we might see over here in whatever country this is over here. I should be better at geography, but it looks like it's south of Russia. Kazakhstan, maybe. I'm going to take a guess. So again, ecosystem, an area, and all the living stuff and non-living stuff in it and how it interacts. Biome, just a type of ecosystem.
All right, are we going to jump back to a math question now?
Perfect.
Jump back to math.
Sound
Kick it back
good?
to you guys, math
Right.
people.
Okay, so this one is about a manufacturing plant. Manufacturing plant can machine parts at a rate of 7 parts every 3 minutes. If the plant continues to produce parts at this rate, how many machine parts will be produced in 3.5 hours?
Okay, so I'm just writing some of that information down. So we want to know, so this machine can machine parts, 7 parts every 3 minutes, whatever these parts are. And if they can produce parts at this rate, we want to know how much they can produce in 3.5 hours. All right. So I have a way that I normally would do this, but after being on this show for the last year, I've seen kind of a way that Becca does it that I think is a little bit more clear.
Oh.
So I think I've learned a little bit about how to set this up a little bit more clearly. I typically would do something like 7 divided by 3 times 60 times 3.5, and I feel like that can be a little confusing. So I'm going to try Becca's way of explaining this, so please feel free to interject if I'm messing it up.
Sounds good.
Or if it's not very clear.
Sure. I'm
doing
sure
it.
it'll be
You're doing it.
great. I'm sure.
Because you do it like kind of proportions, right?
Yeah.
So that's what I'm going to try to do. I usually just say how many can they do in a minute. I convert it into an hour, which is really,
So you do
what
a
you're
unit
doing.
rate, and then you project a unit rate.
but I like the way that you do it because it looks fancy. All right. So we're going to set up a proportion. Every 3 minutes, 7 parts are machined. So we could say 7 parts for every 3 minutes. I'm unfortunately not going to write as neatly. So that's one of the proportions. And we're saying that we can do this every 3 minutes. And in the end, we want to know how many we can create in 3.5 hours. So we kind of want to convert these minutes into hours. So times, I'm going to say 60 minutes for every 1 hour. Right? That's how you would set it up, right? Mm-hmm. Okay. So now we have this proportion. We have 7 parts for every 3 minutes, and we have 60 minutes for every 1 hour. And we can kind of just multiply. We just talked about dividing fractions. And Becca mentioned multiplying fractions. You just multiply straight across.
And the simplifying on the
And
numerator and the denominator before we multiply.
And the simplifying. So we're actually going to simplify first. Like one of the things Becca mentioned was like we had an 11 in the numerator and denominator. We can cancel those out. Well, in this case, we can do that too. And we can think, well, we got minutes here, and we got minutes here. So minutes divided by minutes, these would cancel out. We could also simplify further if we wanted to. And we can say I've got 60 up here. Do this in a different color. I'll highlight it. And we've got 3 here. So we can do that division and say, now I have 7 parts times 20 minutes. I can make this 20, and I can make this 1. And then we can multiply straight across, and I get 140 parts. Right? So 7 times 20, and I didn't get rid of the parts, so 140 parts for every 1 hour. Right? Mm-hmm. And then, so we figured out how many per hour, and now we can say, well, what are we actually trying to figure out? I want to know how much this plant can make in 3.5 hours. So now I can simply take that 140 parts per hour and multiply it by that 3.5 hours. And you should get, what, 420, 490 parts? Let me double check that with my calculator. 140 times 3.5, yeah, 490 parts. So that's how you kind of set it up and work that out with proportions. Is there anything that you would explain a little further?
That was perfect.
All right.
And the reason this is so great is because it's hard to know sometimes, are we multiplying or are we dividing? And when
Right.
are we multiplying and when are we dividing? But if you set it up with the units like that, then you know exactly what you did and what units you're in, and then how to maybe get to exactly what you want.
Another reason why I like this way is a lot of times, you know, in the end, we could say 490 parts per hour, or you could do that divide by hour. And I think a lot of students don't really understand why we do that, like miles divide by hour.
Right.
And setting it up this way with proportions like makes it very clear, like
Yep.
the minutes are canceling themselves out. That's kind of what we're left with.
It's the only way I can make sense of rates and
Right.
proportion.
Your favorite.
I know. It's the only way.
So hopefully that helped.
Yeah. All right, well, let's do one more science question.
Okay, we have somebody over here who would like to know the difference between ionic and covalent bonds.
Okay.
Oh,
Classic chemistry question.
classic.
All right. So ionic and covalent bonds are, so a bond in chemistry is some way that two atoms are held together. And in general, we talk about ionic and covalent bonds. There are some other type of bonds, but we'll leave those for another question. But the two main ones that hold really all molecules together, all compounds together, are ionic and covalent. So an ionic bond is a bond where one atom loses an electron, or maybe multiple electrons, and becomes positively charged. And another atom gains electrons and becomes negatively charged, because electrons are negative particles, so the loss of them will make you positive or more positive, whereas gaining them will make you more negative. But let's take a look at my screen. I've got an animation that'll sort of show this. So in the animation, you can see sodium is losing an electron, giving it to fluorine. Sodium's now a little bit positive, fluorine's a little negative, and it's that positive-negative combination that creates literally an electromagnetic effect, which holds these atoms together. So we're talking about sodium and fluoride here. When we get sodium fluoride, when sodium and fluorine, the elements come together, you get sodium fluoride, which is table salt. And when you put table salt in water, it dissociates and becomes positive sodium ions and negative fluorine ions. And then if you were to leave that glass of water out and let it evaporate, the water would go away, and the sodium and fluorine ions would find each other again and hook back up and become a sodium fluoride compound. So alternatively, you have this other kind of bonding called covalent bonding. Make it a little bigger. Oh God, that's kind of scary. It's moving really fast, I know. I hope I'm not giving anyone at home seizures, but that's really intense. But the idea here is that in covalent bonding, rather than losing an electron to become positive and hooking up with a negative atom, what you're doing is you're going to share an electron with another atom, because, and this is something that we don't have time to get into too much right now, but in general, atoms are looking to get a certain number of electrons to fill an outer orbital of electrons. So hydrogen would really like to have 2 electrons. Hydrogen only has 1, but that other hydrogen has another one, so they get together, and if they share, they both have 2. And that is what keeps them held together. Covalent bonds are stronger than ionic bonds. And yeah, I think that's about it.
Cool.
Does that make sense?
It did make sense.
Did you guys get seizures from the...
This is a little intense. I
GIF?
agree.
I might have to think about using
I had to
less
look
intense
away.
GIFs.
Yeah. All right, well, we're going to take a little bit of a break, and when we get back, we're going to get to meet the principal clarinetist, Jason Shafer, from the Colorado Symphony.
This is the corner office at Bud's Warehouse.
It is a home improvement thrift store.
The nonprofit sells used home improvement materials. This is Danae Johnson in her calm environment.
I think that's why I went into accounting, because it's peaceful. You don't have to interact with people if you don't want to in accounting.
Credits always go second.
It's a good thing she found the accounting program
And they pay the freight.
here at Emily Griffith.
It was a great value for the buck. I think I learned the basics very well.
Minus 1158.
Her bed of knowledge acquired by Lena Fedenishin.
So you know what that means, right? What does that mean? I'm the accounting instructor.
Oh, Lena's awesome. She's very bright, personality and mind.
100 people are giving me $24 on the first of the year.
And the fact that she can teach 10 students the same thing but 10 different ways, that was always awesome to me.
I think every good teacher learns their students, and every student learns in a different way. I just tune into students. I try to get to know them. You already had your receivable.
For Danae, an instructor like Lena made all the difference.
We'll just hit the 3 and then the % button.
I'm a visual person, and Lena would always find a way, get a piece of paper, draw a picture.
So what we need to do is sort of draw it out. So if I can make them understand the concept in a way that makes it clear for them, then all of a sudden they're able to turn that around and, put the mechanics behind it.
Danae still appreciates her former instructor.
Lena took the time, and I saw her take the time with other students too. That's why I still communicate with her.
She shared with me, from time to time some of the hurdles that she was facing.
The student-teacher bond kept Danae in school.
When I found out I was pregnant, I wanted to quit. When I got hospitalized, threatening a miscarriage, I wanted to quit.
Danae was also homeless, but Lena gave her one word: persevere.
I just really encouraged her. I said, the whole reason that you're here is to do better for, your future, for your children.
Lena is more than a teacher. She's an inspiration.
And she never allowed me to quit. And so I take that with me everywhere. Like, if I can do that, if I can finish school in a year, homeless and pregnant with a kid, what can I do?
Employment in a career she loves is a good accomplishment.
What's your phone number?
I'm just so proud of her.
But the most rewarding part of her day?
I'm gonna research that is when I work with these guys here who are rebuilding their lives from homelessness, drug addiction, and prison.
Bud's Warehouse is on a mission to rebuild lives through career and life skill development programs.
We employ them, we give them job training skills, cash handling skills.
Are these correct?
Lena, the inspiration for Danae to pass the spark.
Move all my numbers balanced.
The opportunity to do something where she's making a difference for somebody else, not just pushing paper, but that she feels good about. I think that goes a long way with her.
I've had a lot of life experiences, some good, some bad, and I try to use those to talk to people and to share and to give somebody encouragement.
And when Danae's confidence drops, Lena's still there.
I feel like, maybe I'm not as good of a bookkeeper as I think I am when I make a mistake, and Lena's really good about, no, Danae, you're great. You know what you're doing. Just think about it. Remember when we did this in class? I'm like, oh, man, yeah, okay, you're right. And so, yeah, she's a good mentor. I told her she'll always be in my life as long as she doesn't turn me away. All right.
Students like Danae are what teaching is all about.
It feels good. It feels good to make a difference for somebody. It feels good to see them succeed. Just makes me feel really good.
Success all the way around.
Welcome back. We're here again with the principal clarinetist, Jason Shafer from the Colorado Symphony. Welcome.
Thank you. Thank you for having me.
So tell us a little bit about what your job is with the symphony.
Yeah, sure. So like you mentioned, I'm the principal clarinet player, and a lot of people don't know actually that the Colorado Symphony is a full-time professional orchestra. So, what we do is actually we rehearse like say a Tuesday through Friday kind of a thing, and then we'll do concerts Friday, Saturday, Sunday, and then be completely off for only maybe one day, and then just start rehearsing again for a completely different concert the next week. And it keeps us, super busy in terms of lots of work. It's a lot of practicing, it's a lot of studying the music. A lot of times, like the week of one concert that we do, I'll be working on the next few weeks' concerts and getting ready for that too. And so I love it though. It's so much fun and really, really enjoy what I do. And on top of that, I also teach as well. I teach at the University of Northern Colorado up in Greeley. So I try to fit that in because I love teaching too, but job in the symphony is just awesome, and I'm so lucky to be part of such a great orchestra.
Sounds like a dream job, getting to play an instrument.
Yeah,
What you
it's
love,
fun.
do what you love all
it's
day.
a lot of work, but it's also really great.
Then I have to ask, how much time do you have to spend? Like you said, you rehearse like Monday through Thursday?
Yeah.
How much time do you actually spend rehearsing with the entire band, and how much time do you spend like rehearsing on your own or just practicing pieces?
Yeah, sure. Some days we'll rehearse 5 hours or more than that, and then which is a lot of playing. Your muscles get a little tired after a little while, and on top of that, a lot of us practice just an hour or two or more than that, even with that rehearsal time. And then on the days we have off, sometimes we'll try to fit in a lot more practice, of course, too.
Wow,
so we don't.
pretty intense.
I know a lot of us say we don't really ever get a real day off, but we do love it. So it's
Wow, that's a lot. What kind of music do you play on your clarinet?
That's a great question. So actually, one of the things I love is that we all think that classical music is maybe just one thing. And actually, really, what it is a whole lot of different kinds of styles and genres. I mean, of course, we do the classical Mozart or Beethoven or what you might think of as a symphony. But, we also get to do a lot of really completely different things, like go to Red Rocks and back up a really great band. One of my first concerts, actually, in this job was playing with the Lumineers at Red Rocks, which was an awesome concert.
I was there.
Oh, that's awesome.
I was there.
I saw you then. Nice. So, but that's what I love about it is because it's hard for me to even say like, oh, do I have a favorite or whatever, because it's so great that every week, even though we're working so hard, like I'll be doing a completely different kind of concert, completely different kind of show. And so, I mean, I've heard some different people, people coming to our concerts, and they'll say things like, "I never thought a symphony could sound like that," and it's really awesome. We love that.
That's really amazing. Would you be willing to play something for us?
Sure, absolutely. Well, talking about different styles of music, one of the things that sometimes we have to do as clarinet players actually is play something that's a little more jazzy, maybe. And there's one composer that I absolutely love called George Gershwin, and he wrote a piece, Rhapsody in Blue, which is this really fun, awesome, jazzy piece. And there's this clarinet solo at the beginning that the clarinetist that played it first actually it was messing around and added this big swoopy gliss thing, and the composer was there and he said, "Keep that, I really want that in the piece." So we get to play that as clarinet players. So I thought I would play it for you, and maybe I can stand up, you might get a little better view of the piano. Yeah. Of the clarinet here, as long as I'm not destroying a wire. We have a lot of fun practicing that a lot. It's hard.
Oh, wow.
Yeah. So definitely a song I'd heard, although I wasn't sure when you said Rhapsody in Blue, but I've totally heard that intro somewhere before.
Awesome.
Yeah.
So you mentioned playing a lot of different genres of music. I have to ask because I'm going to the Symphony for the first time in, I think, January maybe?
Nice.
For the Harry Potter.
Oh, you got tickets.
Are you playing that?
I am playing that show.
He barely got tickets, though, apparently.
Barely. I got the third show.
Yeah, actually, it was amazing because we had 3 shows of that, and our hall is pretty big, seats a little over 2,000 people, and even with that, I think it was within a week all those tickets sold out.
But I think the first showings was in like a day.
Yeah, the same
day.
They
added another one.
Exactly. So. But if you're liking the Harry Potter or other movies, check out our website and you can see some of the other times that we play, like the full movie score with the movie, and you might just see a few more Harry Potters will be coming up.
Oh yeah,
that's
good to
awesome.
know.
You'll be there.
I will put that on my list too.
Yeah,
for sure. Do you play any other instruments?
I actually play piano as well. Yeah, I have to say that it's hard to have enough time, I guess, in terms of practicing more than one instrument. And in the orchestra, we all really specialize on just one, except for percussionists that play so many amazing things. But I do love playing piano on the side still.
That's awesome.
What about do you play this thing here?
Yeah, so
an instrument?
This thing's a little wild. It's actually, if I can tell you a little bit behind the story behind this, here at the Symphony we have a lot of different educational
programs. Can I hold it up so everybody can see it?
Please go for it. Yeah, you might be making a racket here. So, as part of the Symphony, we have a whole lot of educational programs. And what we're doing with those is we're really trying to engage as many students and as many teachers as we can of all ages. And one of the things we love doing are our youth concerts, where a lot of students will come in from various schools, or you can buy a ticket, or you can come on a field trip, and you'll get to see the Symphony play a special program that's really just talking really to that age group. And one of the things that we love to do in the lobby before is kind of have an instrument petting zoo. And so as part of that petting zoo, you get to try all sorts of different instruments, and you get to try a clarinet or a brass or a woodwind, another woodwind, or a stringed instrument. And but sometimes everyone's a little hesitant and scared to try it. And so what we do is, this is called a flexitone. and it's really awesome and fun. And it makes this wild sound if you press it down and shake it. I really wish I could do this as my full-time job. It would be really fun.
That sounds like something they
try?
like as a. Oh, I don't know. I've never played an instrument before.
I'll go for it. And then push.
Look at you.
Yeah, there you go.
You're natural.
Wow.
Nice.
Who knew?
There you go. We all can
So
make
do you have
music.
space in the symphony for
Yeah, right.
Serena?
Oh, absolutely. Come and join.
What would that be used for in?
It sounds like
just
something
sound effects or
from like a sci-fi movie, right?
It
Is that
does.
what
You know what?
Yes.
I
Okay.
have heard this instrument used in a lot of times actually contemporary composers who will create these really wild, crazy works with sounds that you've maybe never heard before will use something like this. And it's really cool when you're hearing all these amazing instruments and suddenly the sound like that comes floating through the orchestra. Yeah. But also on movie scores, you're right.
It's really interesting.
Yeah.
Can you do Happy Birthday on that?
I can try. I
Try.
have to see if I'm more able. You have to be very in control.
Oh, wow.
Wow.
Close. It was my birthday yesterday, though. So
Oh,
happy
happy
birthday.
So I just
belated.
serenaded myself with a flexible.
There you go. Perfect. Perfect.
You know, when we were talking about the educational stuff that we do, I wanted to throw out one other thing, if I could, that's really just awesome, and I'm so excited that we do this at the Symphony, is that any student and any teacher with a valid student ID or teacher ID can come and get tickets for way under the normal price. If you come the day of a show, you can get just $10 tickets, which is awesome. It's so much less than anything else. And if you really are like, oh, I want to reserve that one seat, you could call ahead and get it for only $12. And I think it's amazing because it's just, I've been in a lot of cities where orchestras just have really small halls and they just don't have room for students. And we just really want to welcome all the students, you know, any age, if you're in college or high school or elementary school or middle, and their teachers too, to be able to come and hear us on any of these programs. I mean, please look that up on our website and take a look for that because I think it's awesome that I'm really glad we offer that. So.
Yeah, I'm really glad that you do too, because I took advantage of that.
Awesome!
Did you
Yes.
Yeah.
Good.
So
Nice.
Yeah, that's a really
Perfect.
incredible resource. I didn't
Yeah.
realize it was
Yeah.
for teachers too. That's
Yeah,
Yeah.
absolutely, for sure.
That's really awesome. Anything else you wanted to share about the educational programs or anything?
Sure. I mean, I mentioned a couple already. We do the in-school concerts, which, actually, I was talking before about the kids' concerts that are at the Symphony Hall, where kids will actually come and experience it there. But we also do in-school concerts. We either call them just in-school or petite musique, which is for preschoolers. But we had a former cellist in our orchestra who was actually a composer, David Mulliken, and he wrote these amazing pieces that you can learn about the instruments and tell a story with them at the same time. And we really love to engage kids that way. But another thing that you might want to consider if you're a student and a teacher too is coming to one of our open rehearsals where you can come and watch us work with our conductor and rehearse for a concert. And that can be a really cool experience because you're seeing how we glue everything together and how we try to get it, how in just a couple of days can we put together this really 2-hour crazy difficult music program in just that short amount of time. And I actually, when I was a student, I loved going to those open rehearsals because it was just, I almost loved that more than the concerts. I felt like I was behind the scenes. So, I mean, definitely one of the things I love, again, about the Colorado Symphony is just the breadth of all those education programs. We like to call it Music Curious. And so if you go on our website and you see, there's a little thing at the top that says Music Curious, you can click and see if you're a student and you want to just find out how you can be involved, or if you're a teacher and you're trying to say, hey, I want to take some of my students there. Look at all the different things we offer. It's really exciting for me because I just love getting to be involved with all ages and getting to work with everybody. So I hope that some of you that might be watching might take advantage of that.
And you do personal lessons too?
I do, yeah. Actually, a lot of us love teaching. It's really fun. I mean, I've taught students as young as 5 and as old as, I think, 85. So,
wow.
And it's great.
Wow.
Big range.
Anyone
Yeah.
can learn.
Yeah.
Wow, that's really awesome. Well, thank you so much for joining us and telling us a little bit more about all that the Colorado Symphony has to offer. I learned definitely, especially that teachers, I could go there for $10.
Yeah.
Oh, I love it. Love it.
Awesome.
I'm totally doing it.
Well, thank
So-
you for having me, and I'll see you at Harry Potter.
Yeah,
and
see you
hopefully
there.
I'll see you guys another time, too.
Definitely, for sure. All right, well, we're going to take another little break, and we'll see you in just a minute.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
Hi, welcome back. Hopefully you enjoyed hearing from Jason Shafer, the principal clarinetist from the Colorado Symphony. I definitely did. I was really happy to learn all that new stuff. But if you're just joining us, I'd like to give you our contact information one more time. The phone number you see is right on the top of your screen. It's 720-424-1666. But you can also send in your questions on social media. There's the Facebook handle and the Twitter handle. And then you can text us at 970-680-3771 or email us. And that's up on your screen as well. So we're here till 5:30 to answer your questions. That being said, let's go back to Jack and get some questions from social media.
Actually, along with your math or science questions, we also do have a trivia question we'd like to remind you about right about now. The question is, which state in the continental United States has the most navigable waterways? So if you think you know the answer to that, again, the contact information that was just mentioned will be the way you can send that in to us. And there is a prize available for you to win, which I believe is still Symphony tickets.
And how could you not want those after talking to Jason, really?
Most certainly.
Yeah.
All right, so the question we are going to be jumping to is a math question. How can you find the volume of a cylinder?
Yeah, I guess I can take that one. Before we talk about volume of a cylinder, I kind of want to just talk about what volume is for a second. And I think volume of a cylinder in particular, if you think about like, this is kind of a cylinder shape. It's a little irregular, but it's got that like round top. The cylinder is going to be straight down. But if we think about what volume is, it's basically like how much stuff can you put in here. And if you think about like a really quick, easy kind of example that seems to make a little bit more sense to begin with, if we think about like the volume of a cube, and if I just sketch this really quick, see how this looks. Well, when you think about how it's related to area, area's got two dimensions where it's just like how much can you fit on this kind of flat surface, if that makes sense. Whereas when we talk about volume, we're trying to actually think about something more realistic, like how much can you fit inside of this space. So when we think about this, we have, like of a cube here, we have length, we might have width, and then we have height. So we're multiplying all of those together. And if you think about like how do you find the area of a rectangle, like down here, you know, if you think about a cube, Well, a cube is made up of a square right here, and then we multiply it by the height because we need to kind of calculate and include that third dimension, right? When we talk about just like the area of a flat rectangle or a cube, you only have 2 dimensions, length and width. So in volume, we're adding that third dimension of height, which is why when you figure out like the volume of a cube, we do length times width times height. And if that's in inches, that's why we're always going to say inches cubed, because we have 3 dimensions. So I think a lot of students get thrown off when they think about like a cylinder or a shape that's not a cube, because it seems like a little bit more complicated. But I'm going to sketch a cube really quick using this tool. So it looks a little bit, or not a cube, sorry, a cylinder. So this is a quick cylinder right here. We can kind of again think, in particular a cylinder, we have a very specific equation for it, because when you think about this, it's really like a circle that's been stacked on top of a bunch more circles, right? So every circle within here is the exact same size because it's just going straight up and down. So same idea that we were doing with the cube. Think about like, how would I find the area of this circle that makes up the base? And how would I include that third dimension of the fact that this has actually some height here? So really quick, we'll just think about like, what is the area of a circle? And that is area equals pi r squared. So that's just going to give me the area of that like, bottom circle piece. But we have to consider this third dimension of the height here, right? Because again, we're kind of just stacking those circles all the way up. So when we have volume, we're going to say, we're going to look at the area, pi r squared, but then we're going to multiply it by that other dimension. Think like I have some number of circles stacked on top. So if I wanted to find the volume of a very specific cylinder, I would need to know the radius. So let's say the radius was 3. And I would also need to know the height. And so I'm just making up some numbers here, maybe a height of 4. All you're going to do is plug this into the equation. Volume equals pi. My radius is 3, so I'm going to do 3 squared times a height of 4. And then I'm going to simplify that, and I'm going to get 9 times 4, which is 36, or 36 pi. This would be your most specific if this were in inches. This would be inches cubed. But one thing I like to tell students to think about is like, let's say you were trying to find the volume of a can. If you told somebody like, oh, the volume of this can can hold 36 pi inches cubed of soda, that wouldn't really make a lot of sense. So this is one of those examples, like think about what you're being asked. And I would actually do this in my calculator, and I would simplify this into a decimal, 113.097 inches cubed, depending on how precise you want to be. So when you think about volume, think about like what you know about the area of kind of sometimes like the main shape, and this will change based on the figure you're looking at. And then think about like how you could incorporate that third dimension into it. So hopefully that helped.
Yeah, I liked that. I found this online on illuminations.nctm.org, what you were talking about with the layers, just playing around with it. So this is kind of, it's a net of rectangular prism, and you kind of see the layers of those.
Oh, that's really cool.
Of that.
I'm going to have to use that actually. Where did you find that?
Illuminations.nctm.org.
All right.
Yeah, and you can build it by row, so you can see why it's multiplying each time.
Yeah, it's a great
why
resource.
is it length times width times height?
I've just been getting a whole bunch of cubes and putting them in a box. That takes a long time.
So long.
Why not do it digitally?
Yeah, I'm going to have to try that.
All right, let's go back to Jack and see if we have any more questions.
So I hate to discriminate, but we have another math question, unless we have something.
There's 2 of them, lest we forget that there are 2 of them, and only, only one of me.
True.
Unless we have something that you'd like to tell us about science, we can jump into this math question.
No, I would love to give Becca the opportunity to answer the quadratic question.
Okay, so why and when is it appropriate to use the quadratic formula?
That's a good question. Is the question on? Okay, the question's on why we would use the quadratic formula to solve a quadratic equation, I'm assuming. Okay, let me give you, I'm going to see if I can't pull up some examples. Actually, let's do this. So there are, all right, I'll just demonstrate this myself. All right, so there are quadratic equation. Let me first explain what the heck that is. A quadratic equation is something that has a degree of 2, meaning a squared. There is the highest power in the equation or function is a power of 2 that's on your variable. So this right here, y equals x squared, is the most basic quadratic equation that we have. And there are a lot of different forms of quadratic equations. One form is called factored form, and I'll show you. This is kind of the basis of what factored form looks like. And factored form is really nice because solutions in quadratic equations are also our roots. And so a factored form, you don't need to use the quadratic formula because if you can get it in factored form, you can use what's called the zero product property to find your roots. You can actually kind of just see what your roots are if you're in factored form. So no need for quadratic formula when your quadratic equation is in this form. There's another form called Vertex Form, and it looks like this. This is a useful form when we're graphing because the vertex is represented by the coordinates hk. And solving this type of quadratic equation can be done by undoing or just isolating x. What you might notice here or isolating the variable. What you might notice here is that there is only one variable present in this equation. And because there's one variable, we can isolate it by using our inverse operations. So again, no need for the quadratic formula. When a quadratic equation is in this form, general form, this is the form it must be in order to use the quadratic formula. Let me pull up, instead of writing it, I'll pull it up real quick, I'm sure. Quadratic, I don't know why it's disappearing. Okay. So the quadratic formula was actually derived by isolating x when the equation was in general form. Now, we don't have to do all of these complicated algebraic steps every time. We just jump to the very end and plug in our coefficients. And that's what we're doing when we're using the quadratic formula. Now, so we can use it anytime that the quadratic equation is in general form, like this up here, this ax squared plus bx plus c equals 0. We can use it anytime. However, we must use it in the case where we have imaginary roots. Oh, actually, take that back. You can have imaginary roots for vertex form, but it's particularly helpful if we're in general form and the roots or solutions end up to be imaginary numbers, which if you're working with quadratics, hopefully that's familiar to you because I could talk about that for a while. And then also it's really useful to use if you have some messy numbers as your solution because you can't easily, in that case, put it into factored form like this one again on the top here. So long answer, we'll put it in a short way, is as long as it is in general form on the bottom, this one, then you can use the quadratic formula to solve your quadratic equation. All right.
Yeah, I like that you explain all the different forms because I think a lot of times students are like, why do I have to learn all these different forms? But some are just more easily translated if they're written, like you mentioned, vertex form. Like you can just quickly look at it and see what's happening, whereas like another form, you might have to like think about it or rewrite it in some other way.
Exactly. And the quadratic formula is meant to save us time. It might not seem like it, but it's meant to save us time so that we don't have to go through all of those steps that you saw on my screen to isolate the variable. So that's what's nice about it. All right. Well, it seems like we haven't had a caller for the trivia question. I might just have to take those Symphony tickets.
I know. I wish I would have known that, and I wouldn't have bought the Harry Potter ones.
Might just have to take them. Well, Jack, tell us about the trivia answer.
Okay, so again, the question was, which state in the continental United States has the most navigable waterways? The answer to that question is Kentucky. So, although Kentucky is the 37th largest state in the United States, it has the most navigable waterways other than Alaska. We do just want to point out continental United States because Alaska is not part of the continental United States. That's why Kentucky's the winner. So the United States Armed Corps of Engineers says that Kentucky has over 1,900 miles of navigable waterways. Kentucky doesn't only have 1,900 miles of navigable waterways, but also 90,000 miles of streams. 90,000, that's a lot of stream. So it provides one of the most extensive stream systems in the United States. So Kentucky actually is the only state also that is bordered by 3 different rivers: the Ohio River to the north, the Mississippi River to the west, and the Sandy River and Tug Fork to the east. So, yeah.
A lot of water there. Speaking of, so they have a land mass of 40,408 square miles, and of that, 921 square miles of the state is covered in water. So that works out to, and do your math, works out to 2.3% of the state that's actually covered in water. The longest river is the Green River. That's the longest river in the state of Kentucky, is the Green River, which is 382 miles long. So a lot of water there.
Yeah, that makes Kentucky a cool place for a lot of different reasons. My favorite reason is Mammoth Cave. So
Yes.
Kentucky is really cool because it's a karst region, so it has lots of limestone, and all those rivers flowing through the limestone create extensive cave systems. So Mammoth Cave is the longest cave in the world. It's 405 miles long, 400 and something miles long. It's like about 400 miles long, which is pretty incredible. There's a belief that there might be some longer cave systems in China that we haven't found, but up to this point, and I'm a big cave fan, so Mammoth has always been a place to me that I feel like is
Have you
a very
been?
cool place. I've been one time. I've never done like the wild caving tours at Mammoth, which would be my choice. But,
I did just the touristy one.
I just did the walkthrough.
Yeah.
But I really want to go. There's this super cool story. Mammoth Cave is 400 miles long, but there used to be a 250-mile cave and a 150-mile cave that were next to each other. And this little tiny lady, Pat Wilcox, climbed through a crack, found a connection between the two, and it became now a 400-mile cave.
Oh, wow.
Wow.
Yeah.
So I actually used to climb in Kentucky a lot, so I was kind of surprised to hear that there was so much water in Kentucky. But then thinking about it now, like the Red River Gorge is considered one of the best climbing areas in the world, and it would make sense because those are all formed from
Is it all
water,
limestone rock
right?
there?
What's that?
Is it all limestone rock there? Do you know what kind
I
of?
think so, but I'm not really sure.
Cool.
I never really focused on that.
But the gorge itself, unquestionably, was formed by
Yeah.
water.
Yeah.
It's a good state. It's a really
And also
good
one
state.
of the largest producers of coal, speaking of that.
Oh, well, there you go.
So I was actually reading here that Kentucky produces a lot of coal, and in one year, they shipped almost 16 million tons of coal using the Kentucky waterways.
Yes. All right. Well, we are about to say goodbye. I'm sorry. Catch us tomorrow. You can send in your questions to us via social media. If you drop them off there, we can get you tomorrow if you didn't get your question answered today. But I really want to see a trivia winner tomorrow is what I really want to see. So stay tuned on that trivia question for tomorrow. And yeah, I don't know. Do you guys have anything else to add to our viewers before we say goodbye?
No, I think I'm all set.
4:30 to 5:30 tomorrow. Oh, speaking of Kentucky, Kentucky Derby. I don't know what to say about it, other than I've been there 5 times and it's awesome. Kentucky, woo! All right, we're going to see you tomorrow. And that being said, send in those questions. Bye, guys.